All right, so I've cleared the screen and I just want to show you a few more things to get you comfortable with what we're doing so you can use it to your maximum benefit. First of all, let's do something easy like 4.25 plus 11 halves. That's just a calculation we're doing where we're taking this decimal plus 11 divided by 2. There's no symbol anywhere, so we expect MATLAB to return this answer. And we've been doing this all day, but if you inside of the symbol operator wrap a decimal plus a division, no matter what you wrap in the symbol operator, in other words, MATLAB is going to attempt to treat the answer as a fraction, a pure number, so 39/4, right? Let me retrieve the last calculation. We get 39/4. We got 39/4 for this calculation. Now, if I wanted the decimal equivalent of this, I could do the calculation again, sure, but there's a command that will take this last answer and convert it to a decimal number, and that command is double. And if you take double and take the last answer and stick it in there, you're going to get 9.75 out, which is the same thing you get when you actually perform the calculation. So keep that in mind. Anytime you have, let's say you're doing some arithmetic, 102 divided by 317, 416 divided by 1078. Let's do something that's not so easy to do by hand. So I'm taking a symbol, I'm adding these two giant fractions together. MATLAB is going to give me this very large fraction. Look at this very large numerator, this very large denominator. Okay, that's wonderful, but that's not very compact. So I decided, you know what, I don't want to look at this as a fractional form anyway. I can just recalculate the answer. I could just take this part and dump it into a new command line, sure, but I can also just say double answer. Take the last answer. Notice here the answer is a symbol variable because it's a fraction. Let me go ahead and hit double. It changes the last answer back to a numeric value, 0.7077. So basically the command double takes something and converts it to a decimal. And we can practice using our help here if we want by looking at that. Let's type in double into the help browser, hover over this, and let's see what happens. Double, when you pass something to double, it returns the double precision value for x. If x is already a double precision array, double has no effect. So what it's telling you is it takes a value, or it's also telling you that it could be a vector, it could be a range of values, and it's going to take them and try to convert it to double precision. Double precision is another word for decimal, basically. So don't worry so much about why is it called double. That's computer jargon. Double means convert to decimal. All right? Now I want to show you one more thing before we close. Let me clear the screen. Let's do the calculation 4.25 plus, let's say 5.75, right? Something that we all know we can do. Actually, let's change it from 7. Let's go to 5.25 like this. Okay, we all know that we're going to get 9.5 as an answer. So let's retrieve this guy, the last thing that we entered by hitting up arrow on the keypad. Now let's do 4.25 plus symbol. And let's change the 5.25 to 5 1/4. So 5 plus 1/4, like this. Let's look at this for a second. What do you think MATLAB's going to do? Well, first of all, it's going to look inside the symbol operator and it's going to say 5 plus 1/4. So it's going to try to treat this as a fraction, and it's going to give me a fractional answer for this. And because I'm asking it to treat it as a symbol, right? So I'm going to take this fraction answer and I'm going to add it to a decimal. So you've got to be a little bit unsure of yourself. Well, is MATLAB going to treat the answer as a decimal? Or is it going to try to convert the whole thing to a symbol? It's got to pick one or the other because I'm telling it to add a pure symbol to a decimal. Let's see what MATLAB actually does. It gives us the answer in fractional form. It changes a variable back to a symbol operator. So what I'm trying to teach you here is that anytime you have a calculation that includes a pure number like a decimal, a double precision number, and a symbolic number, MATLAB is going to attempt to keep the answer in symbolic form. It's going to try to keep it as pure as possible for you. So just keep that in mind if you mix these things together with the decimals and the symbolic numbers. It's going to try to keep it in fractional form or symbolic form. And if you require that in decimal form, you can just type double, answer, and then you have the answer is 9.5, which is what we got at the top of the screen. That's about all I want to say today. I really encourage you to dig out MATLAB, type some fractions in, reproduce some of the things that I've done here on the screen for yourself, and get comfortable with dealing with fractions, double precision numbers like we've done here, and the symbolic numbers. Because, we've kind of just scratched the surface. We've just talked about fractions, right? Fractions are something you can do in your calculator, but sometimes on the computer you want to do a quick calculation and you don't want to dig out your calculator. But more importantly than that, this whole symbol thing, it's not just applicable to fractions. I mean, don't you think it'd be a little silly for them to give you an entire symbolic math toolbox just to deal with fractions? I mean, of course not. Symbolic math goes way beyond this. Symbolic math in MATLAB is going to let you do things like simplify polynomials, like do synthetic long division of algebraic, expressions, and keep the answers in algebraic form. But you're going to have to define them as symbols. And so we're going to kind of, as we go through the rest of the course, we're going to learn MATLAB from the point of view of this decimal representation, but I'm also going to go through and teach you how to deal with the symbols so that you can get your pure algebraic answers as well, because you'll end up using both as you go forward. If you're a student and you're using a student license either at your school or if you purchased it yourself, you've already got the Symbolic Math Toolbox installed. There's a chance if you're a professional in your company that they may not have purchased the Symbolic Math Toolbox. If that's the case, if you don't have it, if you don't see it up here, then you can basically skip any section in the course where I'm talking about symbolic math. But it's not going to really hurt your understanding of MATLAB because most people are using MATLAB for the numeric capabilities anyway. So I'm going to kind of take some detours and teach you the symbolic math as we go along just because I think it's useful. But certainly if you don't have that capability, it's not going to hinder your understanding or it's not going to hinder your ability to use MATLAB for some very impressive numerical calculations. So dig out your copy, play with it, make sure you understand it because as we go through the rest of the course, we'll be talking about symbols in MATLAB quite often.